This is our EPRI solid particle erosion poster. The objective of our project is to develop a non-invasive monitoring system for solid particle erosion within a combined cycle plan. We have two main project specifications: keep it non-invasive and then monitor erosion with limited maintenance required. The main design components is an industrial piezoelectric sensor, an Arduino Uno, sensor casing, and hardwire communication. The data communication will be a hardwire connection between the sensor and Arduino, and then Python will analyze the data. Here you can see the sensor casing. It will be made from stainless steel, and there will be two pins welded to the valve casing for attachment. The bottom picture is a box that we created to hold the Arduino and solderable breadboard. For the spindle models, there will be 4 different spindles of varying thicknesses that we'll use to analyze the change in frequency due to erosion. The top graph represents a minimally eroded spindle, and the second image represents an extremely eroded spindle. The graphs have 2 lines, which one is measuring the amplitude at a given frequency in red, and the other is the phase angle at a certain frequency in green. A 1 Newton force is applied to the bottom of the spindle to measure the natural frequency. Simulated data is based on the system being stopped and taking measurements then. No other vibration should exist when measuring because the simulated data is based on the impulse given from the impulse hammer. The natural frequency was measured in areas where total deformation occurs. The spikes in the amplitude represents the natural frequency. It is seen that the natural frequency increases as the spindle is eroded. The relationship can be seen as mass decreases, then as a result the natural frequency should increase as well. To determine when the fracture will occur, it is simulated from past fractures that have happened and the diameter at which it was fractured. It is then simulated and the natural frequency is given. After simulating many test samples around the same erosion, the natural frequency for the fracture of the spindle can be determined. In conclusion, the vibration design will limit the amount of maintenance taking place overall. The design is completely non-invasive and can be removed at any point. There's a strong correlation between loss of mass and an increase in frequency. And lastly, design can be easily manufactured. Thank you.